Effects of ozone depletion. A reduction of ozone in the stratosphere results in a greater amount of UV radiation striking the Earth's surface. This can lead to potential damage to the world's ecosystems as organisms become exposed to this high-energy radiation. UV radiation can damage cells that are exposed to the atmosphere. In human beings, this can lead to skin cancer, degradation of the eyes, and weakened immune systems. Some researchers believe that many species of amphibians, such as frogs, are especially susceptible to damage from depleted ozone. These organisms have sensitive skin, making them more likely to be damaged by UV radiation. The ozone hole. Today, the National Aeronautics and Space Administration, NASA, and the National Oceanic and Atmospheric Administration, NOAA, have advanced satellites to monitor ozone levels around the world. The continued monitoring of stratospheric ozone revealed an alarming decrease in ozone gas over Antarctica. For the past 20 years, data has revealed that ozone over the South Pole has depleted rapidly. The low concentration of ozone gas over Antarctica is known as the ozone hole. The formation of the ozone hole over Antarctica occurs during the Antarctic spring, between the months of September and November. Since the 1950s, the amount of seasonal ozone over Antarctica has been reduced by 60%. A similar ozone loss also occurs over the North Pole during the Northern Hemisphere's spring season. These reductions have amounted to approximately a 20 to 25% loss of ozone. Other parts of the globe are experiencing ozone loss. The mid-latitudes, including the US, Europe, and Australia, typically have experienced a reduction in ozone of approximately 4 to 6%. Studies reveal that the loss of ozone is related to an increase in UV radiation reaching the surface. On average, a 10% reduction in ozone can lead to a 10% increase in UV radiation at the surface. A 30% loss of ozone can lead to a 50% increase in UV radiation striking the surface. And a 60% loss of ozone, such as in the Antarctica region, can result in an increase of UV radiation at the surface of almost 150%. Doctors have found there is a direct relationship between increased exposure to UV light and skin cancer in humans. The statistics reveal the actual threat to the Earth's surface that ozone depletion may cause. Reducing ozone depletion. As scientists discovered that the chemistry of ozone destruction was being caused by chemicals such as CFCs, governments throughout the world began to control the use of these gases. In 1996, CFCs were completely banned around the world. However, leftover CFCs that are still in the atmosphere continue to destroy ozone. Old refrigerators and air conditioners in wrecked cars located in landfills and junkyards will continue to leak CFCs into the atmosphere for many years. These chemicals will take between 50 and 100 years to be removed from the atmosphere by natural processes. As the concentration of CFCs drops, the ozone layer will begin to rebuild itself and return to its natural state, but it is a slow process. Until then, careful monitoring of ozone depletion will be necessary to provide information about how much UV radiation is reaching the Earth's surface. Protecting exposed skin from the sun can help lessen the impact of these potentially harmful forms of radiation. This includes the use of sunscreen, wearing hats and sunglasses, and reducing the time your skin is exposed to the sun. Scientists hope the biosphere will not be too adversely affected by this period of increased UV radiation. Ozone depletion provides yet another example of the impacts human technology has on Earth's systems. It also reveals that with careful scientific study and governmental cooperation, many environmental threats can be controlled. Recent studies have indicated the ozone layer over the northern hemisphere should be restored in the mid-2030s, and the Antarctic ozone hole should disappear in the 2060s.